everyone, today we're going to go over lesson 6-2, inverse functions and relations. So the property of inverses state that f and f to the negative 1 are inverses if f of a equals b, if and only if f to the negative 1 of b equals a. And so what we're saying is that we pick a value that we plug into f of f, and so in this case they chose 6. So they did f of 6, which when they simplified they get 2, and then for the inverse that they have x plus 4, they plug in 2, and when they simplify they got 6. If these two numbers, what you started with and what you finished with, match, then yes, they are inverses of each other. If they did not match, they would not be inverses of each other. There was no specific reason as to why they picked the number 6 to start off with. You can pretty much pick any number. Typically, we stay away from the 1, -1, and 0, just because they get some false answers sometimes depending on the function we are using. And always pause the video as needed. So to find the inverse of a relation, we can look at the ordered pairs. So sometimes that is what they'll give us instead of an equation to find the inverse of. So to find the inverse of this particular rectangle that has the vertices of 1, 3, 6, 3, 6, 0, and 1, 0, that's actually very easy to go ahead and do this. All we would have to go ahead and do is flip the coordinate points, which is just switch x and y. So our 1, 3, 6, 3, 6, 0, 1, 0 becomes 3, 1, 3, 6, 0, 6, and 0, 1. And as you can see, if we plot the points, we can see they were a reflection over the y equals x line, which shows they are inverses. So all inverse functions at the moment that we are going to be looking at are reflections over the y equals x line, which would basically show why we switched just x and y. All right, pause the video to give this problem a try. Okay, so we have -3, 4, -1, 5, 2, 3, 1, 1, and -2, 1. All we need to go ahead and do is flip the coordinate points. So we get 4, -3, and with just doing that 1, we know the answer is D. So again, that was just showing us the property of inverses. To find and graph the inverse, so here we have -1/2 x plus 1. We're going to find the graph for the inverse and then graph the inverse. So the first thing we're going to do, step 1, is replace f of x with y. So just that we have it written as y equals. Sometimes this is done for us, sometimes it's not. So in this case, that's one of the things we need to do. Step 2 is interchange x and y. Literally, you just flip the x and y values. So, or the x and y coordinates. So what we'd have, where we see a y, we write an x, and where we see an x, we write a y. Next, we solve for y. Pretty much all the work when we're finding the inverse is done in step 3, which is just isolating y. So here we're going to subtract 1, or in this case, we're going to multiply by -2 on both sides, and then add 2 to both sides, which gets y by itself. You could have also done the subtract 1 from both sides and then multiplied by -2, kind of just a preference of how to simplify it. And then we're going to replace y with f to the -1 of x. This is how we know we are dealing with inverses when we have this notation. So our inverse equation is going to be -2x plus 2. So we can go ahead and graph these, and we'll see that they are a reflection over the y equals x line. And you can just come up with a table of values to plot to graph. So go ahead, pause the video, give this problem a try. All right, so looking here, we have 1/3 x plus 6. So the first thing you would have done was switch x and y to get x equals 1/3 y plus 6. So I would subtract by 6 and multiply by 3. And in doing that, we get C. So another option we do have is if you have gone over composite functions, you can find that if they are inverses, if you take f of g of x equals x and g of f of x equals x. So this is an option you have. So find the inverses of f of x equals x squared minus 4x plus 1, and then graph the function. So this is one of the cases where we would have to go ahead and solve for y. When we do this, we're going to go ahead and want to change this into another format. So what they're doing here is completing the squared, which is basically rewriting the quadratic as in factored form or vertex form. And when we do that, we'll find that y equals 2 plus or minus the square root of x plus 3. And as usual, pause the video as needed. Our last step, of course, is to replace y with f to the negative 1 of x. In this case, we also have an extra step of finding the restricted domain. And this is because of how the graph of quadratics looks. And so we're only going to take the 2 to infinity domain. So if the domain is restricted to the 4 to infinity, find the inverse of x squared minus 8x plus 10. Pause the video as needed to go ahead and give yourself time to work this one out. Okay. You should get d for minus the square root of x plus 6. So now we're going to take a look and determine if 3/4 x minus 6 and 4/3 x plus 8 are inverse functions. So we're going to do f of g, which means I'm going to plug in g of x for every x I see for f. And so when we simplify, we do get x. We then take g of f, which means everywhere I see an x and g, I plug in whatever f is. And we find that yes, they both equal x, so therefore they are inverse functions of each other. You do have to check both. You can't just go with one of them and see if it's true or not. Sometimes one will work, but the other will not. Go ahead and check your work or try this problem. All right, and you should find that since both inverses, they are inverses because both compositions equal x. That is the end of the video for 6-2. I will see you next time.